Here we're being asked to sketch the graph of f of x equals x cubed minus x squared minus 11x minus 10. And we're going to start with the zeros. To get the zeros, we need to factor this. And since it's a cubic polynomial, we're going to have to guess the first factor. So I'm going to use the remainder theorem. So I'm going to guess f of 1, and I'm just going to see if it equals 0. So I get 1 minus 11 minus 10. Well, that's not equal to 0. Okay, and really I don't really care what it's actually equal to. I just want to know whether it's equal to 0 or not. Here we get negative 1 minus positive 1, that's negative 2, plus 11, that's going to be positive 9, minus 10. Well, that's going to give me negative 1, which is not equal to 0. So I'm going to try negative 2. When I plug negative 2 in, I get negative 8 minus positive 4, so that's negative 12, plus 22, that's going to give me positive 10, minus 10 is going to give me the 0. So here's my factor. It's going to be x plus 2. So then I need to divide to break down this polynomial. So I'm going to use synthetic division. So 1, negative 11, negative 10. I'm going to use the root and subtract. So I'll get 1. So negative 1 minus 2 is negative 3. 2 times negative 3 is negative 6. Negative 11 minus negative is going to give me plus 6, which means I get minus 5. I multiply, I get negative 10. I subtract that, I get my remainder of 0. And that's what I'm looking for. These coefficients then give me the quadratic x squared minus 3x minus 5. Okay, so there's my quadratic. I have my 0. I've got one of them at negative 2. Okay, and it goes through there. I just have to find the other one. I'm going to try factoring this, but there's no two numbers that multiply to negative 5 and have difference of 3. So I'm going to use the quadratic formula to solve for that x. So I get x equals negative of negative 3 plus minus negative 3 squared minus 4 times a times c. And that's all over 2. Okay, when I simplify this out, I get 3 plus minus square root of 29 all over 2. Okay, this gives me my roots. Those roots are approximately, when I plugged it into my calculator, 3 minus root 29 divided by 2 gives me negative 1.19 approximately, so maybe right about there. Okay, so I've got another root there. And then if I add plus root 29 and then divide by 2, I'm going to end up with positive 4.19. And so I get another root somewhere right over here. So those are my 3 roots. I kind of know what this graph looks like. I have an idea anyways. This graph essentially is going to, since it's got a positive leading coefficient, it's going to go through here. It's going to have y-intercept at negative 10, probably keep going and somewhere like that. Okay, so that's what we're imagining this graph to look like. We have the zeros, we have a y-intercept to work with, so we have the general idea. Now at this point, we want to find the turning points or inflection points, so we need a derivative. So differentiating this, we end up with, differentiating the original expression, we're going to end up with the derivative f prime of x is equal to, it's going to be 3x squared minus 2x minus 11. And since this is not factorable, we're going to have to use a quadratic formula to solve for the zeros of this, which are going to give us our min and max points.